ಹಲೋ ಎವ್ರಿವನ್, ವೆಲ್ಕಮ್ ಟು T.T.T Academy ಯೂಟ್ಯೂಬ್ ಚಾನಲ್. ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ BMRCL ರಿಕ್ರೂಟ್ಮೆಂಟ್ ಬಗ್ಗೆ ಯಾವ ಟಾಪಿಕ್ನ ಓದಬೇಕು ಆ್ಯಂಡ್ ಯಾವುದೆಲ್ಲ ಟಾಪಿಕ್ನ ನೀವು ಫೋಕಸ್ ಮಾಡಿದ್ರೆ ಹೇಗೆ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಕ್ರ್ಯಾಕ್ ಮಾಡ್ಬೋದು ಅಂತ ತಿಳ್ಕೊಳ್ಳೋದ್ರ ಜೊತೆಗೆ ಒಂದು ಕ್ಲಾಸ್ ಡೆಮೋ ಕೂಡ ನಾನು ನಿಮಗೆ ಪ್ರೊವೈಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಲಾಸ್ಟ್ ತನಕ ನೀವು ವಿಡಿಯೋನ ವಾಚ್ ಮಾಡೋದ್ರಿಂದ ಕ್ಲಾಸಸ್ ನಮ್ಮಲ್ಲಿ T.T.T ಅಕಾಡೆಮಿನಲ್ಲಿ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ನೀವು ಡೀಟೇಲ್ ಆಗಿ ತಿಳ್ಕೊಳ್ತಾ ಹೋಗ್ಬೋದು. ಮೈಸೆಲ್ಫ್ ಡಾಕ್ಟರ್ ಸವಿನಾ JP, and in our academy we are conducting a BMRCL class also. Suppose in this video very beginning I am going to discuss about what are the different syllabus for BMRCL examination with respect to mechanical portion. Suppose if you look at mechanical portions here, now major agi strength of material subject na ಓದಬೇಕಾಗುತ್ತೆ. Theory of machines are also going to call it as mechanics of machines. Next, thermal engineering, fluid mechanics, material science, measurements, workshop technology and manufacturing technology. So these are the different topics you have to focus. So ಇವಿಷ್ಟು ಟಾಪಿಕ್ ಕವರ್ ಮಾಡಿದ್ರೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 15 ಮಾರ್ಕ್ಸ್ ಈಸಿಯಾಗಿ ನೀವು ತಗೊಳ್ಬಹುದು. ಹಾಗಾದರೆ ವೆರಿ ಫಸ್ಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಟಾರ್ಟ್ ವಿತ್ ದಿಸ್ ಡೆಮೋ ಸೆಷನ್. ಈ ಒಂದು ಡೆಮೋ ಸೆಷನಲ್ಲಿ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ಟಾಪಿಕ್ನ ನಾನು ಡಿಸ್ಕಷನ್ ಮಾಡ್ತೀನಿ. ಆ ಒಂದು ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ಫಸ್ಟಿಗೆ ನಾವು ಥಿಯರಿನ ಫೋಕಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಆಫ್ಟರ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ದ ಥಿಯರಿ ಪೋರ್ಷನ್ ದೆನ್ ವಿ ಕ್ಯಾನ್ ಡಿಸ್ಕಸ್ ದ MCQs ಕ್ವಶನ್ಸ್. ಇದಿಷ್ಟು ಕೂಡ ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ನೀವು ಲಾಸ್ಟ್ ತನಕ ನೋಡೋದ್ರಿಂದ ನಿಮಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗ್ತಾ ಬರುತ್ತೆ. ಅಡಿಷನ್ ಟು ದ್ಯಾಟ್ ಕ್ಲಾಸಲ್ಲಿ ನಮ್ಗೆ ಕೂಡ ಹೇಗಿರುತ್ತೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ತಾ ಹೋಗೋಣ. ಇನ್ ಅವರ್ ಕೋಚಿಂಗ್ ಕ್ಲಾಸಸ್ಸಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ ಡೀಟೇಲ್ಡ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇರುತ್ತೆ. ಪ್ರತಿಯೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಕೂಡ ಡೀಟೇಲ್ಡ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ದೆನ್ ಪ್ರತಿ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಸ್ ಕೂಡ ಸಪೋಸ್ ಇಫ್ ಯು ಆರ್ ಅಬ್ಸರ್ವಿಂಗ್ ಹಿಯರ್ ಫಾರ್ BMRCL ಎಕ್ಸಾಮಿನೇಷನ್ ಎಲೆಕ್ಟ್ರಿಕಲ್, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್, ಕಮ್ಯುನಿಕೇಷನ್ಸ್, ಮೆಕ್ಯಾನಿಕಲ್, GK. ಪ್ರತಿಯೊಂದು ಪೋರ್ಷನ್ಸು ಕೂಡ ನಮ್ಮಲ್ಲಿ ಕೋಚಿಂಗ್ ನಡೆಯುತ್ತೆ. ಆ ಒಂದು ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂನಲ್ಲಿ ಡೀಟೇಲ್ಡ್ ಆಗಿ ಪ್ರತಿ ಟಾಪಿಕ್ನು ಕೂಡ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋದ್ರ ಜೊತೆಗೆ ಎಲ್ಲ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಸಬ್ಜೆಕ್ಟು ಕೂಡ ಇವೆಲ್ಲ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಇದು ಕೂಡ ಸಬ್ಜೆಕ್ಟ್ ಕ್ಯಾರಿ ಮಾಡ್ತೀವಿ, ಕ್ಲಾಸಸ್ ಕಂಡಕ್ಟ್ ಮಾಡ್ತೀವಿ. ಪ್ರತಿ ವೀಕ್ ಕೂಡ ಮಾಕ್ ಟೆಸ್ಟ್ ಇರುತ್ತೆ, ಡೌಟ್ ಕ್ಲಾರಿಫಿಕೇಶನ್ ಸೆಷನ್ ಆ್ಯಂಡ್ ಕ್ಲಾಸ್ ನಡೀತಿರುವಾಗಲೇ ನಿಮಗೆ ರನ್ನಿಂಗ್ ನೋಟ್ಸ್ ಸಿಗ್ತಾ ಹೋಗುತ್ತೆ ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಸ್ಟಡಿ ಮೆಟೀರಿಯಲ್ಸ್. ದಿಸಲ್ಲೆಲ್ಲ ಫುಲ್ ಏನೊಂದು ಕೋರ್ಸನ್ನು ಅಂತ ಕಂಪ್ಲೀಟ್ ಮಾಡಬೇಕು ಆ ಒಂದು ಡೈರೆಕ್ಷನ್ಸಲ್ಲಿ ಈ ಕೋರ್ಸನ್ನು ನಾವು ಡೆವಲಪ್ ಮಾಡಿರುವಂಥದ್ದು. ವೆರಿ ಫಸ್ಟ್ ಇನ್ ದಿಸ್ ಡೆಮೋಸ್ಟ್ರೇಷನ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸಿಡರ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ಸಿಲೆಬಸ್. ಇನ್ ದ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್ ವಿ ನೋ ದ್ಯಾಟ್ ಯಾವ ಥರ ನಿಮಗೆ ಮೆಟೀರಿಯಲ್ ಕಾನ್ಸೆಪ್ಟ್ ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರಿಂಗಲ್ಲಿ ನಾವು ಇದೊಂದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಸಬ್ಜೆಕ್ಟ್. ಲಾಸ್ಟ್ ಇಯರ್ BMRCL ಕ್ವಶನ್ ಪೇಪರ್ಸ್ನ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಬಂದಾಗ ಫಾರ್ ಸೆಕ್ಷನ್ ಇಂಜಿನಿಯರ್ ಆ್ಯಂಡ್ ಟ್ರೈನ್ ಆಪರೇಟರ್ ಆಲ್ಮೋಸ್ಟ್ 2 to 3 ಕ್ವಶನ್ಸ್ ಫ್ರಮ್ ದಿಸ್ ಸಬ್ಜೆಕ್ಟ್. ಈ ಒಂದು ಸಬ್ಜೆಕ್ಟಲ್ಲಿ ನಿಮಗೆ ಕ್ವಶನ್ನ ಕ್ಯಾರಿ ಮಾಡಿದ್ದಾರೆ. ಸರ್, ಹಾಗಾದರೆ ವಾಟ್ ಯು ಮೀನ್ ಬೈ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ಸ್? The strength of material is nothing but it is mainly focusing upon the material ability under the certain condition. Suppose if you are usually what happen in our surrounding, many materials you are using to build any building or it may be any stresses or in any devices, anything. Suppose all the case here majorly we are going to use a materials. If the material is able to resist or oppose to the applied load, ಓಕೆ. ಯಾವ ಥರ ನೀವು ಲೋಡ್ನ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಯಾವ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲ ಮೆಟೀರಿಯಲ್ ನಿಮಗೆ ಎಬಿಲಿಟಿ ಇರುತ್ತೆ ಆ್ಯಂಡ್ ಅಪೋಸಿಷನ್ ಮಾಡುತ್ತೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಬರ್ತೀವಿ. ಸ್ಟ್ರೆಂತ್, ಎಬಿಲಿಟಿ ಟು ವಿಸ್ಟ್ಯಾಂಡ್ ದ ಲೋಡ್. ದಟ್ ಈಸ್ ವಾಟ್ಸ್ ದ ಹಿಯರ್. ಸಪೋಸ್ ಇನ್ ದಿಸ್ ಒನ್ ಆಫ್ ದ ಸಬ್ಜೆಕ್ಟ್ ದ ಬ್ರಾಡ್ಲಿ ಇನ್ ಎ ಸಿಸ್ಟಮೆಟಿಕ್ ವೇ ಆಫ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ದಟ್ ಸಿಸ್ಟಮೆಟಿಕ್ ವೇ ಆಫ್ ಸ್ಟಡಿಂಗ್ ಇನ್ ದಿಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಮೆಟೀರಿಯಲ್ಸ್ ದಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ಡ್ ಆಸ್ ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್. ಸಿಂಪಲ್ ವೇ it is defined as it is a branch of engineering science which deals with the ability of various type of material to resist its failure under the action of force or action of load. ಫೋರ್ಸ್ ಆಗ್ಬೋದು ಅಥವಾ ಲೋಡ್ ಆಗ್ಬೋದು. ಯಾವೊಂದು ಕಂಡೀಷನ್ಸಲ್ಲಿ ನಿಮಗೆ ಮೆಟೀರಿಯಲ್ಲು ವಿಸ್ಟಾರ್ಡ್ ಮಾಡೋ ಎಬಿಲಿಟಿ ಇದೆಯಲ್ಲ ಅದನ್ನು ಸ್ಟಡಿ ಮಾಡುವಂಥ ಡೀಟೇಲ್ಡ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡುವಂಥ ಸಬ್ಜೆಕ್ಟಿಗೆ ನಾವು ಸ್ಟ್ರೆಂತ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ಸಪೋಸ್ ಇಲ್ಲಿ ನಾವು ಮೇನ್ ಆಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿರೋದು ಇಫ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ಸಿಡರ್ ಎನಿ ಮೆಟೀರಿಯಲ್ ಅಂಡರ್ ದ ಕಂಡೀಷನ್ ಆಫ್ ಆರ್ ಅಂಡರ್ ಎ ಫೋರ್ಸ್ ಆರ್ ಅಂಡರ್ ಎ ಅಪ್ಲೈಡ್ ಲೋಡ್, how it is behaves. Suppose if you are going to applying a load on any material, it's develops some amount of stress and strain. What do you mean by stress? Stress andre eno, strain andre eno adana tilkolbekagutte. With respect to that, suppose in this subject I want to focus mainly about stress and strain. So what is this stress? The stress is nothing but Suppose if you are going to applying a load over any body or any material, it's by its internal energy, it's opposing, it's resisting to the applied load. Suppose if we are going to applying a load to this body or load to this material, the material is resisting that by its internal energy. It means that body molecules ಅಲ್ಲಿ ಇರುವಂತಹ ಎನರ್ಜಿಯಿಂದ ಅಪ್ಲೈಡ್ ಲೋಡ್ ಅದು ಕ್ಯಾರಿ ಮಾಡುತ್ತೆ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡುತ್ತೆ. ದಟ್ ಈಸ್ ಎಸ್ಪೆಷಲಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಸ್ಟ್ರೆಸ್ ಸಿಗ್ಮಾ. ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಈಸ್ ದ ಮೆಟೀರಿಯಲ್ ಈಸ್ ಡಿಫಾರ್ಮಿಂಗ್, if it is changing its dimension, I mean change of dimension to its original dimension, that means deformation of the material, which is expressed by strain, usually denoted by epsilon. Suppose let's move with a first content, that is stress. So stress anta tolodare when some system of external forces acts on the material. Suppose here is a body. For this body, if you are applying a n number of forces, different forces like a 2 kg or 2 Newton, 3 Newton, 4 Newton, different number of forces apply ಮಾಡಿದಾಗ how the material is behaves. So suppose then the internal forces are set up at various section of the material which resist the external force. Whatever the applied load, for that load this internal resistance force which opposition create ಮಾಡುತ್ತೆ, resistance create ಮಾಡುತ್ತೆ. So this internal force per unit area is going to called as stress. In a simple way, the stress sigma is the ratio of external force to the area or cross sectional area. Suppose if you are going to consider this is the body, let's take a rod. This rod I'm applying a force or load on both the ends. Okay, so let's take the load is P on both sides, and the cross section of the body is we can consider as a, that is area A. So then that force per unit area is going to call it as stress. In a simple way we can consider as a stress. So suppose in this stress we are going to classify it as different types of stresses are there. Before that, once again, the stress means it is defined as deforming load to the cross sectional area. Suppose stress equal to force divided by or load divided by area, load by area. If you are going to consider this is a rod, for this rod we are applying a force on both the ends, this side and this side. The load is P. Then the stress is denoted as sigma. Sigma is equal to load by cross sectional area, where load is P and area is A. Then what is the unit of load? Load in a unit the unit of load is, that is Newton, and unit of area is area in meter square. Then ಏನಾಗುತ್ತೆ, then automatically this is in Newton, this is in meter square. Therefore the unit of stress will be in Newton per meter square. It's a simple concept, the load per unit cross sectional area which gives you stress. So next thing is, in this stress there are different types. Among the first one is, that is tensile stress, second is a compressive stress, and third one is a shear stress. Sir, what is this tensile stress? Tensile nothing but it's what elongating the material. If you are applying a load to any material, the material it extends. Suppose hereby I am going to consider there is a rod. Before that I am going to consider that notes. Okay, here you can observe here. So in this body, let's take this is a body. Over this body I am going to applying, suppose let's take a tensile stress. Suppose tensile stress is nothing but, if you are going to consider this is a rod, let's take a rod. For this rod I am going to applying a force P on both ends, the where L is a length of the rod. Then this is what the cross sectional area. This is what elongating, I mean axial pulling. The load is which acts on the axis of the material. So in this case what happened, that is tensile stress is nothing but it is a lengthen or stretch the material as normal to the stressed area. Suppose if you are going to consider this is let's take a cross section area of the body is A, cross section area of the body is A, then the where P is applying on both the sides, P is applying on both the side, then tensile stress is equal to normal pulling force, both sides we are extending pulling force to the cross section area of the body. This is the cross section area, that's A. Then the unit is Newton per meter square, Newton per meter square. So for example, bicycle chain, this is also one of the good example for tensile stress, and tug of war, hagajagata, rope belts drive, and rope of the crane. These are the different examples we can consider as tensile stress. Next thing is compressive stress. So what do you mean by compressive? Let's take a second one is compressive stress. Second one is compressive stress. So in case of a compressive stress, the body is compressing. Let's take this is the material. For this material, we are applying a force towards the body, the load and towards the, it means the material is get compressing. It's compressing. So then ಏನಾಗುತ್ತೆ? Here we can observe here the body, if the compressive force is applied, the stress that compresses the given body, that creates a compressive stress. The stress which tends to compress or shorten the material, that's very important, that shorten the material adds normal to the stressed area. So if you are going to consider this is the axis of the material, towards that the material is compressed. Then compressive stress is normal pushing force to its cross sectional area. That is normal force is N divided by area is in meter square. I mean Newton per meter square. That is unit. Here that stress is generally changes the volume of the body also. If it is the body volume change adre. If you are going to consider the sponge. In case of sponge, what happen? If you are applying a force to that material, sponge material, the butt may get compressed, in which total volume it gets compressed. If the change is compressed, volume, then you can call it as compressed, instead of compressive or volume stress andanu karibodu. Yav case alli? In case of volume changes, its only length decreases, then it is a compressive stress. That is what your second type. Let's move with the third type. What is the third type? That is shearing the material. Suppose instead of axis, if you are going to applying a load over its tangential direction, suppose let's take this is a circle. In this circle, this is a tangent. Here is a tangent. If you are applying a load in this cross sectional way, then its tangential force per unit cross sectional area. Let's take this is the body. For this body, if you are applying a force in this way, that means that the skin is twisting. That is the force which is acts on the tangential direction of the body, a tangential direction of the material. So then the shear stress can be defined as, ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, that is tangential stress which defined as, shear stress is also known as tangential stress, is defined as intensity of resisting force acting parallel or tangential to the plane of unit cross sectional area. That means again it's same, it's usually denoted by tau anta ನಾವು denote ಮಾಡ್ತೀವಿ. That is again force by area only. Shear stress tends to distort the shape or twist the material. So you can observe here. Suppose this is a body. For this body I am applying a force, means it's not twisting like. It means it distorts the shape of the material. The shape ne change ಮಾಡಿಬಿಡುತ್ತೆ. ಯಾವ stress shape ne change ಮಾಡುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರೆ that is shear stress, in which shear stress acts. So if you are going to consider here there is a glue. Between that there are two body. One body is extending or elongating this side, another body is elongating this side. There are two different forces. Between that here is a shearing force act ಆಗ್ತಿರುತ್ತೆ ಈ portions ಅಲ್ಲಿ. So shear stress is denoted by tau, which equal to tangential force per unit cross sectional area. The unit is remains same, Newton per meter square. So these are all the different types of stresses. Next thing is strain. So what do you mean by strain? Suppose if you are going to consider the strain. So in case of a strain, the strain is usually denoted by epsilon. Epsilon ನಾವು denote ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. The strain is defined as a system of forces acts on a body. It undergoes some deformation. body dimension may changes. Suppose if you are elongating over the any material, I mean load apply ಮಾಡಿದ್ರೆ the body length may changes or body dimensions may changes. Dimensions, it may be length or width or depth or diameter, different dimensions. If the change of dimension to original dimension, that is going to called as strain. So this deformation per unit length, we can observe here, deformation per unit length, okay, that we can call as deformation. Again, per unit length ಗೆ ನಾವು ಎಂತ ಕರಿಬಹುದು, we can express as a strain. So very important ಆಗಿ ಏನಂತ ತಿಳ್ಕೊಂಡ್ವಿ ಈಗ, strain ಅಂತ ಹೇಳಿದ್ರೆ ಏನಂತ. Suppose when some system of external force acts on a body, the body undergoes some deformation. This deformation per unit length, let's take this is a rod. For this rod I am applying a force on both ends. The force is P. Then the length of the body is L. After the application of the force, the body length this may changes this much. Clear, right? So initially this is, then this much is a change of length. The change of length, that is you can consider as delta L. So therefore initial length is L. After the application of the force, the length is increased. That epsilon is equal to change of length by original length. Change of length by original length, that is going to called as strain. So only a change of length, even though it may change of its diameter also, or in case of a bar means width, depth or breadth, there are different change of dimensions. So yaudanaru tagonda, that is simply we can call it as a strain. That means the change of dimension to the original dimension. In case of length, that is length in millimeter suppose, and even the length, change of length in millimeter, this also millimeter, finally it's get cancelled. Then it is a unitless quantity, unitless quantity, unitless quantity. So that is what your strain. Unit illa, ಇದಕ್ಕೆ no unit ಅಂತ ಕರೀತೀವಿ. No unit ಕೇಳಿದ್ರೆ ಕ್ವಶನ್ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ, ಯೂನಿಟ್ ಲೆಸ್ ಇರುತ್ತೆ ಇದಕ್ಕೆ. Next, the strain is defined here. The strain is defined as when a system of force acts on under body, it undergoes some deformation. The deformation per unit length is going to called as strain. Deformation per unit length is going to called as strain. Same thing, so you can observe here, that is elongation. Elongation means change of length, delta L, you can observe here, change of length to the original length. It is again unitless quantity, unitless quantity. Dear students, so ಇಲ್ಲಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಂಗೆ ಹೇಗೆ ನಾವು ದೇರ್ ಆರ್ 3 ಟೈಪ್ಸ್ ಅನ್ನು ಓದಿದ್ವೋ, ಇನ್ ಕೇಸ್ ಆಫ್ ಎ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಓದಂಗೆ ಸ್ಟ್ರೈನ್ ಅಲ್ಲೂ ಕೂಡ ನಾವು ಮತ್ತೆ 3 ಟೈಪ್ಸ್ ಅನ್ನು ಮೇಜರ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಅಂಡ್ ದಟ್ ದ ಫಸ್ಟ್ ಈಸ್ ಟೆನ್ಸೈಲ್ strain, compressive strain, shear strain. Let's move it one by one. Tensile strain. What do you mean by tensile strain? Here in this, the body elongating. Let's take this is the body. For this body, applying a force here on both ends. If you are applying a body, the body length may increases. This is a change of length, that is they can consider as delta L. Initial length is L. Initial length is L. After the application of the force, this is what change of length, increase ಆಗಿರುವಂತಹ length. So that increase of length by original length, that's you can call it as a tensile. That means in case of a tensile, it's extending, it's elongating. That is the condition. So it means when a body is subjected to axial pull, the result which the body tends to extend its length. The increase in length to the original length is going to called as tensile strain. Increase in length to original length ಗೆ ನಾವು tensile strain ಅಂತ ಕರೀತೀವಿ. Next thing is compressive strain. What do you mean by compressive? Instead of increasing in case of a tensile, if the body is get compressed, the length decreases. The decrease of length ಅನ್ನು ನಾವು ಡಿಸ್ಕಷನ್ ಮಾಡೋದು ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ, that is what your compressive strain. See, observe here, when body is subjected to axial push, in case of this is the rod. For this rod, if you are applying a load towards the material, towards the body length may decreases and its diameter may increases. This is what change, decrease of length. Initially the original length is L. After the application of the axial push, length decreases. What is the amount of decreased length? Which is delta L. Decrease in length delta L to the original length L. That gives you compressive strain. Again, no unit. The strain antela bandaga, it is a unitless quantity. Next thing is shear stress. What do you mean by shear stress? The shear stress is nothing but, suppose if you are going to consider, here is a body. For this body, I am applying a force at this side, P, or load at this side. Due to the application of the load, the body may deviate like that. So illinda ilige enagutte, body shift ago chances irutte because of the force which acts on the tangential direction of the body. In a shearing, the body with twisting, it's twisting like that because the force which is acts on the surface of the material, a tangential direction. So the reason the body may twist in this way. Suppose if you are elongating here, illi now jaasti force agre enagutte, illinda illi shift agutte this point. That we can consider as delta or dx. That I am going to express as dx. And illinda illi length ideyala, distance between two layers. Here is a body. For this body, this is the one layer, this is the another layer. There are two layers are here. So one layer and another layer. Where the distance x anta tagolteni. Let's take a x. So this is what x, and illinda change agirodeno, that is dx. Now that is lateral displacement between two layers is dx, and distance between two layers is x. So the shear force is defined as, if the deforming force produces the change in shape of the body. The questions ಕೇಳುವ chances ಇರುತ್ತೆ, ಯಾವ ಒಂದು stress or strain ಅಲ್ಲಿ body shape change ಆಗುತ್ತೆ. The shape change ಆಗೋದು ಯಾವುದು? Shear stress or shear strain ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ನಿಮಗೆ shear strain ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಿರುವಂತದ್ದು. therefore ಏನಾಗುತ್ತೆ ಇದೀಗ, body shape change ಆಗುತ್ತೆ without changing its volume. Body shape change ಆಗುತ್ತೆ, but not a body volume change ಆಗಲ್ಲ, but does not change its volume, only it changes its shape. That is going to called as shear strain or shearing strain. So it's also defined as, it is a ratio of lateral displacement between two layer to the distance between two layer. What is the lateral displacement? Which is dx, and distance between two layer is x. So dx by x, that is what your shear strain. So this is a concept with respect to three strains. So first one is tensile strain, second one is compressive strain, and third one is shear strain. So next, let's move with Hooke's law. What do you mean by Hooke's law? The Hooke's law is nothing but, whenever you are going to applying a load to any material or any body, the body dimension may changes. So certain load, the body may deviate. After the removal of the load, the body regains. Suppose if you are applying a force to this body, if you are applying like the force, the body may deviate or deform. After the application, removal of load hakadna remove madidre vapas barutte, straight ಆಗಿಬಿಡುತ್ತೆ. Suppose let's take this is one of the specimen. For this specimen, both the side applying a force P, ಎರಡು ಸೈಡ್ ಅಲ್ಲೂ ಕೂಡ force apply ಮಾಡೋಣ. The body may be extend ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. If that remove that, the body regains ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. So this is we actually state ಮಾಡಿರೋದು ಅಂದ್ರೆ Hooke's law. ಹೇಗೆ ಹೇಳ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, when you are going to applying a force to any body, the body which develops the stress as well as strain also. If it is the body or material within elastic limit, means the stress and strain which are going in a proportional manner. So according to Hooke's law, he is going to state that the stress is directly proportional to stress is directly proportional to strain. Stress is directly proportional to strain. What is stress? Which is sigma. Sigma is directly proportional to epsilon. So this is the concept. On the load apply ಮಾಡಿದಾಗ body may get stress even though strain takes place. After the removal of load, body will be remains its original shape or original form only. So ಅದಕ್ಕೆ ಬರುವಂತ ರೀಸನ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ವಿಟ್ ಮೀನ್ಸ್ ದಟ್ ಸ್ಟ್ರೆಸ್ ಮತ್ತು ಸ್ಟ್ರೈನ್ ವಿತ್ ಇನ್ ದ ಸ್ಟೇಟ್ ಇರುತ್ತೆ, ಎಲಾಸ್ಟಿಕ್ ಲಿಮಿಟಲ್ಲಿ ಇರುತ್ತೆ, ಆ್ಯಂಡ್ ಬೋತ್ ಆರ್ ಪ್ರಪೋರ್ಷನಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್. ಸೊ ಸ್ಟ್ರೈನ್ ಒಂದು ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆಗ್ತಿದ್ರೆ ಸ್ಟ್ರೆಸ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಿರುತ್ತೆ, ಬೋತ್ ಆರ್ ಪ್ರಪೋರ್ಷನಲಿ ಇನ್ಕ್ರೀಸಿಂಗ್. So that is the statement here. So with respect to that, the stress is directly proportional strain within elastic limit. Within elastic limit. Within elastic limit. So you can observe in this graph, here is in a horizontal direction, strain, vertical axis, stress. So ಎರಡು ಕೂಡ ನಿಮಗೆ ಸೇಫರ್ ಜೋನ್ ಇದೆ. That point is, let's take a point. So ಇದನ್ನು ನಾವು ನಿಮಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದು. Suppose what do you mean by stress? The stress is load by area, and what is strain? Change of length by original length. Now the stress is directly proportional to strain. So stress, if you want to remove this proportionality, means by applying a constant we can remove, like that equal to E into epsilon. What is E, sir? Where E is elastic constant. Elastic constant. ವೇರ್ನ ನಾವು ಎಲಾಸ್ಟಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತ ತಗೋತೀವಿ. ದೇರ್ ಫೋರ್ ಇಫ್ ಯು ಕೀಪ್ ಇಟ್ ದೇರ್, ಈ ಅಲ್ಲೇ ಇಟ್ಕೊಂಡು ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಸ್ಟ್ರೆಸ್ ಬೈ ಸ್ಟ್ರೈನ್ ಈಕ್ವಲ್ ಟು ಇ, ಆರ್ ಎಲ್ಸ್ ಇ ಈಕ್ವಲ್ ಟು ಸ್ಟ್ರೆಸ್ ಬೈ ಎಪ್ಸಲಾನ್, ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಲಾನ್. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ಹುಕ್ಸ್ ಲಾ ಸೇಸ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ಹುಕ್ಸ್ ಲಾ ಈ ಒಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ಅನ್ನು ನೆನಪಿಟ್ಕೊಂಡಿರಬೇಕು. ಸ್ಟ್ರೆಸ್ ಅಂಡ್ ಸ್ಟ್ರೈನ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ. ಸೊ ದ ರೀಸನ್ ವಿ ವಿಲ್ ಗೆಟ್ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಫ್ರಮ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಟು ದಿಸ್ ಪಾಯಿಂಟ್. See, this is the point. That point is A. So this is a statement we can observe here. This is a statement na navilli observe ಮಾಡಬಹುದು. Next, ಈ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು, even though we can draw a stress strain graph for any material, here in this case I am going to consider the mild steel, where mild steel is a ductile material. So it sudden ಆಗಿ ನಿಮಗೆ ಫ್ರಾಕ್ಚರ್ ಆಗಲ್ಲ, some deformation ಆಗಿ after it may break. So in this case, if you are going to consider the test specimen, mild steel test specimen, here I am applying a force on both ends. Due to the application of the external force, then the body may deform. It's take yielding. See, you can observe here yielding or necking. That means that reduce ಆಗುತ್ತೆ. Even increasing the load limit, that may get break. Chances of breaking irutte nimgali. So before going to break, necking takes place. In that time, if you are going to draw stress and strain graph, what do you mean by stress? Where stress is nothing but sigma, which is load divided by area. Another thing is strain, epsilon. So strain is nothing but change of length by original length. Simple. Here there is a load P. If you are increasing the load limit, that load is go on increases, starts from 1 Newton, 2 Newton, 3 Newton, 4 Newton, and even the strain takes place. Change of length takes place because of application of the load, increase of load. So that means change of length may be starting at 0.1, next 0.2, 0.3. That length may increases. As load increases, the stress also takes place. Stress value ಬರ್ತಾ ಹೋಗುತ್ತೆ because load is increasing. Change force by area. So the reason stress value ಬರ್ತಾ ಹೋಗುತ್ತೆ. Even though due to that load, increase of load, change of dimension ಆಗ್ತಾ ಇದೆ. Change of dimension ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ that even though material is straining, that means ನಿಮಗೆ change of length by original length ನ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು strain value ಕೂಡ ತಗೊಳ್ಬೋದು. By considering these two value, we can draw stress and strain graph. Stress is sigma and strain in horizontal, that is epsilon. By drawing these two, we can get this graph. So what this graph explain? ಈ graph ಏನು ಹೇಳುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, just we can observe here, this is the initial condition. At this point to this point, the stress is directly proportional to strain, which is stated by Hooke's law. Hooke's law ಪ್ರಕಾರವಾಗಿ ಏನಾಗಿದೆ, ಇಲ್ಲಿಂದ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಇದೆ ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು. The stress is directly proportional to strain at this point. Here the material within elastic limit. After crossing this limit, the material is changes in a plastical way. That means that permanent deformation ತಗೊಳ್ತಾ ಹೋಗುತ್ತೆ. Permanently the material is deforming. Then here in this point yielding takes place. Then again ನಿಮಗೆ maximum load ತಗೊಂಡು it will be breaks here. You can observe this is a specimen. If you are applying a load, some deformation ಆಯಿತು. So the deformation, that means change of length by original length. Here is load by area. So as the load increases, stress also increases, even that elongation, change of length, due to that we can draw a strain. So at this point material ಏನಾಗ್ತಿದೆ ಇಲ್ಲಿ taking a permanent compared to this length ಜಾಸ್ತಿ ಆಗಿದೆ, necking ಆಗಿ ಉಳಿದಿದೆ, I mean extension ಆಗಿರೋದೆ this range. Now this is a maximum limit where the material is extended. So we can observe here the material is necking takes place permanently, it changes its shape. So this is where maximum stress produces this point. Illi produce ಆಗೋ ಸ್ಟ್ರೆಸ್ಸಿಗೆ ನಾವು ultimate stress or maximum stress point ಅಂತ ಕರಿತೀವಿ. At this point, even though small application of the load, increase of load, the material necking ಆಗಿರೋದು sudden fracture ಆಗುತ್ತೆ, ಕಟ್ ಆಗಿ ಹೋಗುತ್ತೆ. That is what fracture point. This is what stress strain graph for mild steel. For a ductile material, ನಾವು ಈ ಒಂದು ಪಾಯಿಂಟ್ ನ yield point stress ಅಂತ ಕರೀತೀವಿ. This is yield point stress. This is for ultimate stress or maximum point stress. This is what allowable stress. ಇಲ್ಲಿ ಬರುವಂತ ಸ್ಟ್ರೆಸ್ ಗೆ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್, ವರ್ಕಿಂಗ್ ಸ್ಟ್ರೆಸ್. ವಾಟ್ ಎವರ್ ದ ಮೆಟೀರಿಯಲ್ ಆರ್ ಎನಿ ಡಿವೈಸಸ್ ಯು ಡೆವಲಪ್, ಯಾವುದೇ ಒಂದು ಡಿಸೈನ್ ನೀವು ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಡಿವೈಸ್ನ ಡೆವಲಪ್ ಮಾಡಿದ್ರೆ ಅಲೋಬಲ್ ಸ್ಟ್ರೆಸ್ ಕಂಡೀಷನ್ಸ್ ನಾವು ಇಟ್ಟಿರ್ತೀವಿ. ಇಫ್ ಇಟ್ ಈಸ್ ಗೋಸ್ ಬಿಹೈಂಡ್ ದ್ಯಾಟ್ ಅದು ಸೇಫ್ ಆಗಿರಲ್ಲ. ವೆನ್ ಎವರ್ ಯು ಅಪ್ಲೈಯಿಂಗ್ ಎ ಲೋಡ್ ಬ್ರೇಕ್ ಆಗೋ ಚಾನ್ಸಸ್ ತುಂಬ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಈಸ್ ದ ಪಾಯಿಂಟ್, ಅಲ್ಟಿಮೇಟ್ ಸ್ಟ್ರೆಸ್ ಬೈ ದಿಸ್ ಅಲೋಬಲ್ ಸ್ಟ್ರೆಸ್ಸಿಗೆ ನಾವು ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಸೇಫ್ಟಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಟಾಪಿಕ್ ಈಸ್ ದಟ್ ಈಸ್, before that, this is a graph for ductile material and brittle material. So what is ductile material? Ductile material is nothing but the material made fracture after some deformation. ಅಂದರೆ ಲೋಡ್ ಅಪ್ಲೈ ಮಾಡಿದ ತಕ್ಷಣ ಮೆಟೀರಿಯಲ್ ಡಿಫಾರ್ಮ್ ಆಗಿಬಿಡುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಇವೊಂದು ಅಪ್ಲಿಕೇಶನ್, ಎಕ್ಸ್ಟರ್ನಲ್ ಅಪ್ಲಿಕೇಶನ್ ಲೋಡ್ನ ಇನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದಾಗ ಮೆಟೀರಿಯಲ್ ಬ್ರೇಕ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ವಾಟ್ ಇವರ್ ದಟ್ ಟೈಪ್ ಆಫ್ ಮೆಟೀರಿಯಲ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ಡ್ ಆಸ್ ductile material. It means that material before fracture some deformation takes place. Let's take aluminium. If you are ವಿತರ ಮಾಡೋ ಅಲ್ಯೂಮಿನಿಯಂ ಏನಾಗುತ್ತೆ, some deformation ಆಗುತ್ತೆ. After the deforming it may get break. That is ductile material. Even the mild steel, rubber, these are the common thing. Suppose if you come into the brittle material, means without any appreciable deformation sudden fracture takes place. Let's take the example is glass. The glass is a material, if you are applying a load to that, sudden fracture takes place, sudden break ಆಗುತ್ತೆ. That type of material is going to called as brittle material. So brittle material graph ಹೇಗಿರುತ್ತೆ ಅಂದ್ರೆ stress strain graph, ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಏನಿದೆಯಲ್ಲ, this is what your Hooke's law statement ಪ್ರಕಾರವಾಗಿದೆ. Stress is directly proportional to strain, both are proportional ಇದೆ. After that sudden fracture ಆಯಿತು. In case of a ductile material like a mild steel, see this is what a elastic limit and stress is directly proportional to strain, yielding ಆಗುತ್ತೆ, ಡೌನ್ ಬಂದ್ಬಿಟ್ಟು this is a maximum stress and breaking point. So this is a ductile material ಬರುವಂತ graph, especially for mild steel. So these were the things we have to analyze, because in the year of 2016 there is a question by considering this concept. Next concept is that is factor of safety. So what do you mean by factor of safety? The factor of safety nothing but it is also going to called as safety factor andanu karithi. Factor of safety also going to called as safety factor. It is what the term describing the load carrying capacity of the material. What amount of load material can carry, adana ನಾವು express ಮಾಡುವಂತದ್ದು this one. This is, suppose the breaking stress or ultimate stress to the working stress is going to called as factor of safety. Just you can observe here. Here is a graph. In this is a yield point. This is ultimate stress. Suppose this ultimate stress to normal working stress. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಇರುವಂತ ಸ್ಟ್ರೆಸ್ ಏನಿದೆಯಲ್ಲ, this is going to called as working stress. Working stress or allowable stress. This limit. ಮೇಲ್ ಹೋಗಿರೋದು ಇಲ್ಲಿಂದ ಇದು yield point stress, and this is what ultimate stress. Now just you can observe here. So for the ductile material, yield point stress to working stress or design stress. This working stress, design stress anta karitivi. One more name is that allowable stress, normal condition stress, where the stress is directly proportional to strain. So that is working stress. So factor of safety is yield stress to working stress for ductile material. ಸಪೋಸ್ ಬ್ರಿಟಲ್ ಮೆಟೀರಿಯಲ್ ಆದರೆ ಸಡನ್ ಆಗಿ ಫ್ರಾಕ್ಚರ್ ಆಗುತ್ತೆ, ಮ್ಯಾಕ್ಸಿಮಮ್ ಲಿಮಿಟ್ ಈಸ್ ಅಲ್ಟಿಮೇಟ್ ಸ್ಟ್ರೆಸ್. So we can observe here this point. So in this point, that is what breaking, sudden breaking agutte, brittle material. This is only a ultimate, that is the ultimate stress. So ಏನಂತ ತಗೊಳ್ಬೋದು ಇಲ್ಲಿ ಈಗ ultimate stress to working stress, that is for brittle material. ಅವನು ಯಾವ ಕ್ವಶನ್ ಯಾವುದು ಕೇಳಿದೀನಿ ಅನ್ನೋದು ಮ್ಯಾಟರ್ ಆಗುತ್ತೆ for brittle material or ductile material. Based on that you have to answer. So in a standard way, the factor of safety is maximum stress to working stress or design stress. That ratio is going to called as factor of safety or safety factor. Safety factor. So next, that is what the concept here. This safety factor is going to consider for different value with respect to the different materials. Different value for different materials. Suppose for steel, usually we are going to consider as 1.83. For concrete 1.5. For timber 4 to 6. This is what safety value for different material. So once again, factor of safety means which is breaking stress to working stress or ultimate stress to safe stress. That's it. So now based on this theory, I am going to discuss about a few MCQs question. It should be very useful to you. So first question, if you look at here, this is the question they asked in many times. This is JE question paper question 21 ನಲ್ಲಿ ಕೇಳಿರುವಂತದ್ದು. Hooke's law holds good up to, and same question even though GPSC mechanical 2019 and ISRO ನಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ 2016 ನಲ್ಲಿ. Hooke's law holds good up to what? Hooke's law is stress is directly proportional to strain within elastic limit. Up to elastic limit, within elastic limit. See, observe here where C is the right answer. Because stress is directly proportional to strain within elastic limit only. So the reason our Hooke's law holds good up to elastic limit. That's the same thing we can observe here. That means stress sigma is directly proportional to epsilon. Directly proportional to epsilon. That is the concept here. So Hooke's law holds good up to elastic limit. Next question. The unit of stress in SI unit. Unit of stress in SI unit. So in SI unit means Newton per millimeter square or kilonewton per millimeter square. So and Newton per meter square. Everything is come into picture. So we can consider as which is in all of the above ಅಂತ ನಾವಿಲ್ಲಿ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಹೋಗೋದು. ಬೇರೆ ಬೇರೆ ಯೂನಿಟ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಆನ್ಸರ್ ಬರುತ್ತೆ. ದಿಸ್ ದ ಕ್ವಶನ್ ಅಗೇನ್ ಆಸ್ಕ್ಡ್ ಇನ್ ಮೆನಿ ಕ್ವಶನ್ ಪೇಪರ್ಸ್. ಸೊ ಲೋಡ್ ಪರ್ ಯೂನಿಟ್ ಏರಿಯಾ, ಲೋಡ್ ಇನ್ ನ್ಯೂಟನ್ ಆ್ಯಂಡ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಇನ್ ಏರಿಯಾ. ಏರಿಯಾ ನಾವು ಮೀಟರ್ ಸ್ಕ್ವೇರಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್, ಸೊ ದಿಸ್ ಇಸ್ ಅ ಕ್ವಶನ್ ಪೇಪರ್ ಕ್ವಶನ್. BMRCL question paper question, especially in the year of 2016 suction engineer question paper. The factor of safety is the ratio of dash. What is factor of safety? So which is yield stress to working stress. Yield stress to working stress. So this is what I answer for your BMRCL 18 question ಗೆ in the year of 2016 ಕೇಳಿರುವಂತದ್ದು. So tensile stress by working stress alla, compressive stress no, even bearing stress to yield stress no. So yield stress to working stress, that ratio is going to called as factor of safety. Next question is again one more question in the year of 2016 but train operator question paper. Station control and train operator ಕೇಳಿರುವಂತದ್ದು. The ratio of shear stress to shear strain. I discussed about shear stress and shear strain. The ratio of shear stress to shear strain is going to called as rigidity modulus or shear modulus or modulus of rigidity anta karithi. You know, this is usually denoted by G, which is equal to shear stress to shear strain. Shear stress to shear strain. That ratio is going to called as rigidity modulus. So this is the ratio for this. Answer is are also going to call as modulus of rigidity. Modulus of rigidity. This is the answer. Again this, we can observe here ಏನು ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋದಲ್ಲ ಟಾಪಿಕ್ ಅದ್ರ ಮೇಲೇ ಕ್ವಶನ್ ಕೇಳಿದಾನೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ ಮೋರ್ ಕ್ವಶನ್. ದ ಯೂನಿಟ್ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಇನ್ SI ಯೂನಿಟ್ ಈಸ್ ಅಗೇನ್ ಸೇಮ್ ಕ್ವಶನ್. ಎನಿ ಆಫ್ ದಿಸ್ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಆಗ್ಬೋದು ನಿಮ್ಗೆ ಆನ್ಸರ್. ಎಲ್ಲದೂ ಕೂಡ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ಎನಿ ಆಫ್ ದಿಸ್ ಇವನ್ ನ್ಯೂಟನ್ ಪರ್ ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್, ನ್ಯೂಟನ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್, ಕಿಲೋ ನ್ಯೂಟನ್ ಪರ್ ಮಿಲಿಮೀಟರ್ ಸ್ಕ್ವೇರ್. ರಿಪೀಟೆಡ್ ಕ್ವಶನ್. The deformation per unit length is dash. Deformation per unit length. Deformation means change of length to the original length. That is strain. Strain. So simply we can consider as strain. This is the right option. because change of length by original length is a strain. Next, the unit of strain is what? The unit of strain. So strain is epsilon, change of length by original length. Let's take this is in meter, even this also in meter. So meter get cancelled. It means no unit. It is a unitless quantity. Therefore, D is the right answer. Next question is, strain is equal to, that is strain is epsilon, change of length by original length. Therefore, B is a right answer. One more question. Hooke's law holds good up to dash. Again same question. Elastic limit. Hooke's law holds good up to elastic limit. Whenever material is loaded within elastic limit. Next question. The stress is directly proportional to strain. Sigma is directly proportional to strain. Therefore, B is the right answer. So this is a way we are going to explain in the classes. ನಮ್ಮ ಒಂದು ಕ್ಲಾಸ್ ಸ್ಟ್ರಕ್ಚರ್ ನಿಮಗೆ ಈ ಒಂದು ವೇನಲ್ಲಿ ನಾವು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಇಸ್, ಚೇಂಜ್ ಇನ್ ಲೆಂತ್ ಡ್ಯೂ ಟು ಟೆನ್ಸೈಲ್ ಆರ್ ಕಂಪ್ರೆಸಿವ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ಎ ಬಾಡಿ is given by. What is change of length? See, it's a simple thing. If you are going to consider, here is a stress. So what do you mean by stress? The stress is denoted by sigma, which is equal to load by area. What do you mean by strain? The strain is change of length to the original length. Now, according to Hooke's law, the stress is directly proportional to strain. A stress is equal to E into strain. A strain ಈ ಕಡೆ ತಗೊಂಡ್ರೆ stress by strain equal to Young's modulus. Suppose, so Young's modulus is equal to stress by strain. So Young's modulus is equal to, what is stress? The stress nothing but P by A whole divided by, what is strain? Change of length by original length. Therefore, E equal to, if you send here P by A into ಮೇಲ್ಗಡೆ ಹೋದಾಗ L by delta L. Now the question here is, what is the deformation or change in length? Change in length means delta L. So how to find delta L? If you send this delta L to this side, ಏನಾಗುತ್ತೆ? Then ಇದನ್ನು ಈ ಕಡೆ ಕಳಿಸ್ಬೋದಲ್ವಾ ನಾವು? Thereby delta L equal to PL, P into L, PL divided by, ಇದು ಈ ಕಡೆ ಬಂದಾಗ AE. That is your option. Just you can observe here. Change in length due to tensile or compressive force acting on a body is given by, that is PL by AE. B is the right answer. Next. So this is what content we are conducting. So ನಮ್ಮ ಒಂದು ಅಕಾಡೆಮಿನಲ್ಲಿ in the evening 6 PM ಇಂದ 9 PM ವರೆಗೂ ಪ್ರತಿದಿನ till the exam classes ಕಂಡಕ್ಟ್ ಆಗ್ತಾ ಇದೆ for BMRCL. So ಎಲೆಕ್ಟ್ರಿಕಲ್ ಪೋರ್ಷನ್, ಎಲೆಕ್ಟ್ರಾನಿಕ್ಸ್ ಪೋರ್ಷನ್, ಕಮ್ಯುನಿಕೇಷನ್ ಪೋರ್ಷನ್, ಮೆಕ್ಯಾನಿಕಲ್ ಪೋರ್ಷನ್, GK ಪೋರ್ಷನ್ ಪ್ರತಿಯೊಂದು ಕೂಡ ಕ್ಲಾಸಸ್ ನಡೀತಾ ಇದೆ. ಎಫೆಕ್ಟಿವ್ ಏನಲ್ಲಿ ನಿಮಗೆ ಕ್ಲಾಸಸ್ ಇರುತ್ತೆ. ಸೊ ಪ್ರತಿಯೊಂದು ಕ್ಲಾಸ್ ಕೂಡ ನಿಮಗೆ ಈ ಥರ ಒಂದು ಕಂಟೆಂಟ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು n ನಂಬರ್ ಆಫ್ MCQs ಕ್ವಶನ್ ಇನ್ ಎ ಸಿಮಿಲರ್ ಮ್ಯಾನರಲ್ಲಿ ಡಿಸ್ಕಷನ್ ಮಾಡ್ತಾ ನಿಮ್ಮ ಜೊತೆ ಕ್ಲಾಸ್ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಜೊತೆಗೆ ನಮ್ಮಲ್ಲೇ ಕೂಡ BMRCಲಿಗೆ ಒಂದು ಮೆಕ್ಯಾನಿಕಲ್ ಪೋರ್ಷನ್ಸ್ ಬುಕ್ ರೆಡಿ ಮಾಡಿದ್ದೀವಿ, ಎಲೆಕ್ಟ್ರಿಕಲಿಗಿದೆ, ಈವನ್ ಈವನ್ EC ಕೂಡ ನಾವು ಸಮ್ ಅದರ್ ಮೆಟೀರಿಯಲ್ಸ್ ಕೊಡ್ತಿದ್ದೀವಿ. ಮಾರ್ಕೆಟಲ್ಲಿ ಬೇಕಾದ್ರೆ ನಿಮಗೆ ಸಿಗುತ್ತೆ, ಅವೈಲೇಬಲ್ ಇದೆ, ತೊಗೊಳ್ಬೋದು. ನಮ್ಮ ಒಂದು ಪಬ್ಲಿಕೇಶನ್ ಕಡೆಯಿಂದ ಮೆಟೀರಿಯಲ್ಸ್ ಕೂಡ ಅವೈಲೇಬಲ್ ಇದೆ. ಸಪೋಸ್ ಬೇಕಂದ್ರೆ ಮೆಟೀರಿಯಲ್ಸಿಗೂ ಕೂಡ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡ್ಬೋದು, ನಮ್ಮನ್ನು ಕೆಳಗಡೆ ಕಾಣಿಸ್ತಿರೋಂಥ ನಂಬರಿಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡ್ಕೊಳ್ಬೋದು. ಜೊತೆಗೆ ಯಾವುದೇ ರೀತಿ ನಿಮಗೆ ಆನ್ಲೈನಲ್ಲೂ ಕೂಡ ಅಡ್ಮಿಷನು ಕ್ಲಾಸಸ್ ನಡೀತಿದೆ, ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ ಕೂಡ ನಡೀತಿದೆ. ಆನ್ಲೈನ್ ಆ್ಯಂಡ್ ಆಫ್ಲೈನ್ ಕ್ಲಾಸಸ್ ನಾವು ಹೈಬ್ರಿಡ್ ಆಗಿ ನಿಮಗೆ ಲೈಕ್ ಕ್ಲಾಸಸ್ ಕಂಡಕ್ಟ್ ಮಾಡುವಂಥದ್ದು. ಎರಡೂ ಕೂಡ ಆನ್ಲೈನ್ ಕಮ್ ಆಫ್ಲೈನ್ ಕ್ಲಾಸ್ ಇರುತ್ತೆ. ನಮ್ಮ ಜೊತೆ ಡೌಟ್ ಕೇಳ್ಕೊಳ್ತಾ, ನಿಮ್ಮ ಡೌಟ್ನ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊಳ್ತಾ ನಮ್ಮ ಜೊತೆ ನೀವು ಕ್ಲಾಸನ್ನು ಅಟೆಂಡ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ಬೋದು. ಆಲ್ರೆಡಿ ಕ್ಲಾಸ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ. ಇವತ್ತು ಮತ್ತು ನಾಳೆಯಿಂದ ಯಾರೆಲ್ಲ ಜಾಯಿನ್ ಮಾಡ್ಕೊಳ್ತಿರೋ ಒಂದು ಕಡೆಯಿಂದ ಪ್ರತಿಯೊಂದು ಪೋರ್ಷನ್ನು ಕೂಡ ನಿಮಗೆ ಕವರ್ ಮಾಡ್ತೀವಿ. ಎಲ್ಲ ಟಾಪಿಕ್ ಕೂಡ ಕವರ್ ಆಗುತ್ತೆ. ನಂಬರ್ ಆಫ್ MCQs ಟೆಸ್ಟ್ ಸಿಗುತ್ತೆ, ಮಾಕ್ ಟೆಸ್ಟ್ನ ನೀವು ತೊಗೊಳ್ಬೋದು. ಸೊ ಪ್ರತಿಯೊಂದು ತೊಗೊಂಡ್ಬಿಟ್ಟು ನೀವು ನಿಮ್ಮ ಒಂದು ಡ್ರೀಮ್ನ ನನ್ಸ್ ಮಾಡ್ಕೊಳ್ಬೋದು. ನಿಮ್ಮ ಒಂದು ಡ್ರೀಮಿಗೆ ನೀವು ವ್ಯಾಲ್ಯೂ ಕೊಡ್ತಾ ಹೋಗ್ಬೋದು. ಸೊ ಯಾರಿಗೆಲ್ಲ ಇಂಟ್ರೆಸ್ಟ್ ಇದೆ ನಾನು ಕ್ಲಾಸ್ ಜಾಯ್ನ್ ಆಗಬೇಕು, ನಾನು ಇದನ್ನು ಒಂದು ಎಕ್ಸಾಮ್ನ ಕ್ರ್ಯಾಕ್ ಮಾಡಬೇಕಂತ ಮೈಂಡ್ ಸೆಟ್ ಇದ್ರೋ ಈ ಕೆಳಗಡೆ ಕಾಣಿಸ್ತಿರುವಂಥ ನಂಬರಿಗೆ ನೀವು ಮೆಸೇಜ್ ಅಥವಾ ಕಾಲ್ ಮಾಡೋದ್ರಿಂದ ನೀವು ನಮ್ಮಲ್ಲಿ ಅಡ್ಮಿಷನ್ ತೊಗೊಳ್ಬೋದು. ಟುಡೇ ಮತ್ತು ಟುಮಾರೋ 2 ದಿನದಲ್ಲಿ ನೀವು ಯಾರು ಅಡ್ಮಿಷನ್ ತೊಗೊಳ್ತೀರೋ ಅವರಿಗೆ ಪ್ರತಿಯೊಂದು ಪೋರ್ಷನ್ನು ಕೂಡ 100% ಆಗಿ ನಾವು ಕವರ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ವಾಚಿಂಗ್ ದಿಸ್ ವಿಡಿಯೋ. ಆ್ಯಂಡ್ ಇಫ್ ಎನಿ ಕ್ವರೀಸ್, ನಿಮ್ಗೆ ಏನಾದ್ರು ಕ್ವರೀಸ್ ಇದು ಅಂತ ಹೇಳಿದ್ರೆ ಚಾಟ್ ಬಾಕ್ಸಲ್ಲಿ ಕೆಳಗಡೆ ನಿಮಗೆ ಲೈಕ್ ನೀವು ಕಮೆಂಟ್ ಮಾಡೋದ್ರಿಂದ ನಾವು ನಿಮ್ಮ ಕಮೆಂಟಿಗೆ ರಿಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಜೊತೆಗೆ ಯಾವುದೇ ಹೇಗೆ ನಾವು BMRCL ಅಪ್ಲಿಕೇಶನ್ನ ಫಿಲ್ ಮಾಡಬೇಕು ಆ್ಯಂಡ್ ಈ ಒಂದು ಪ್ರೀವಿಯಸ್ ಆಗಿ ಒನ್ ಮೋರ್ ಡೆಮೋ ಕೊಟ್ಟಿದ್ದು ಅದರ ಲಿಂಕ್ ಪ್ರತಿಯೊಂದು ಕೂಡ ನಾನು ಈ ಒಂದು ವಿಡಿಯೋ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಹಾಕಿರ್ತೀನಿ. ಪ್ಲೀಸ್ ಗೋ ಥ್ರೂ ಇಟ್ ಆ್ಯಂಡ್ ಶೇರ್ ದಿಸ್ ವಿಡಿಯೋ ವಿತ್ ಯುವರ್ ಫ್ರೆಂಡ್ಸ್. ಥ್ಯಾಂಕ್ ಯು. ಆಲ್ ದಿ ಬೆಸ್ಟ್ ಫಾರ್ ಯುವರ್ ಡ್ರೀಮ್. ಥ್ಯಾಂಕ್ ಯು ಆಲ್.